trim, if anybody wants any help.
I was about to ask that, but then I realized he does it all the
Okay.
time, so I don't question it. Right?
Let's get as much done as we can.
You want the first day. I didn't like it the first day. I liked it the rest of the days.
What are you talking about? Oh.
It says the first day you're like, why am I here? And then once you get into it, you're like, okay.
Okay. All right. Did you have a hand up back there?
Yeah.
We have quite a ways to go yet, so I don't know. It won't be next week, I know that. But Ted makes a very good point. If you look at your assignment sheet, there's a lot of stuff on there because we're doing this whole chapter and there's a lot of sections in the chapter. So you need to be keeping up. We are now in 4.3, so what should be done? 4.1 and 4.2 should be done. And actually some of 4.3 could be done. And after today, maybe most of it. All right, so let's figure out what's going on. We're on 4.3, number 2, which is at the back of page 34. All right, so here we go. Point P is on the terminal side of theta. Find the 6 functions for theta. So we're finding sine, cosine, tangent.
Just the first 4.3 million out.
Yes, but it's at the bottom. Cosecant, secant, cotangent. Now the directions are like, oh my gosh, what's going on? Point P is on the terminal side of angle theta. What that means is simply this. Draw or plot 2, -2. So that would be right here, right? Draw that angle from the origin down to that point. This is the point they gave me, 2/2 down to. So draw that angle in. Then make your butterfly bow tie triangle. Remember, when you draw a triangle, your angles are going to be sticking out like this. When you draw your triangle, it's always to the x-axis. So we're going to have this piece right down here because we went over 2 and down 2. Right 2, down 2 to make that triangle. Now, let's find the hypotenuse. How will we find the hypotenuse? Pythagorean theorem. Remember, in the Pythagorean theorem, everything is positive. Don't you dare put a negative in the Pythagorean theorem because it's squares. So we're going to have 2 squared, which is 4, plus 2 squared, which is 4, equal to c squared. So 8 equals c squared. And c equals the square root of 8. But be careful, there's something special about the square root of 8. What's special about it? It simplifies. Remember how to do that? How does the square root of 8 simplify?
4, 2, 2 comes out.
A 2 comes out and a 2 stays in. Now, how did Geechee know that? Well, 8 is 4 times 2. And what's the square root of 4? 2. I can take the square root of that part, right? So my hypotenuse is 2 square roots of 2. Now I'm going to fill in the blanks. What sign? Opposite. Remember, the angle you look at is the one at the origin always. So this is the opposite side. So -2 over 2 root 2. Now wait a second. See that 2 and this 2? They cancel. -1 over root 2. And I've got to go on the bottom. Good job. So this is going to be -√2 over 2. Boys and girls, we're big kids now. We got to be able to do more than one thing in a problem. if the sign is -1 over root 2, then the cosecant is -√2 over 1. Turn it over. And remember, you can put the negative wherever you want to when you write that fraction. All right, next. Cosine. Let's look at the problem here. What's the cosine? First step. 2 over 2 root 2. So I'm going to write that down. 2 over 2 root 2. Now this doesn't happen very often, but sometimes it does. You can cancel that. So that's going to be 1 over root 2. But like Paul said, you can't have a radical on the bottom. So that's going to be root 2 over 2. Which means the secant is the flip of this. So root 2 over 1. Tangent. Opposite over adjacent, so that'll be -2 over 2, which is 1, -1. Which means the cotangent is 2 over -2, which is also -1. That was a little hard because of the simplifying stuff. Don't get bogged down in it. You can handle it. All right, we're getting ready to go to the next problem. Do we have an issue here? Is there a number up there you don't quite understand where it came from? Phil?
On the sign, why is the cosecant? I gotta understand why you wrote negative square root of 2 over 2, and then negative square root of 2 over 1. But
okay. Well, remember, this is the sign in simplified form. This is the sign in not simplified form. These are my steps to get to the answer. When I flip it, I do not want a radical on the bottom. So instead of flipping this is the actual answer to the sign question. But if I flip it, I'm going to have a radical on the bottom. So instead of flipping that step, I'm going to flip this step. I'm allowed to flip any step I want. And it makes sense to flip this one to get the cosecant, because then there's no radical on the bottom. If I wanted to flip that, I could, but then I'd have to do the simplification on that problem too. And I don't want to do that. So I just flip it here. I do the same thing here. I flip it here. Alright? Okay, let's try the next one. First thing you're going to do is plot your point. So please plot the point -1, 4. And connect it to the origin. That's your angle. There's your angle. Plot the point they give you, which is -1, 4, and connect it to the origin. Now what do? Well, we're going to do the Pythagorean theorem in a minute, but first I need a triangle, right? So I'm going to drop that perpendicular straight down. And then this side would be what? -1, and this side is 4, because that's the point they gave you. Left 1, up 4. Now we'll do the Pythagorean theorem. This one isn't going to simplify. What's the Pythagorean theorem? Root 17. So there's no simplifying here. We're just going to have to use root 17. So here we go. What is the sign? Step 1, Phil, is 4 over root 17. But I'm not allowed to have a radical in the denominator, so I'm going to rewrite that as what?
Root 17 over 4.
No. Now, that's what the cosecant is. The cosecant is the reciprocal. How do I get rid of the radical here? Don't flip it over. How do you get rid of that radical? We multiply the top and the bottom by root 17, so that we have 4 root 17 over 17. That's the actual answer for the sine. The reciprocal is root 17 over 4. That's the answer to the cosecant. What's the cosine? Negative 1 over root 17. So I have the same problem here. I got to get rid of this radical. You can't put this in the answer blank. Well, you can, but you'll miss a little bit of points. How do I get rid of that? I do top and bottom by root 17, which is going to give me negative 1 root 17 over 17. Now, to get that answer, I have to flip it. I'm going to flip it right here, so that I have root 17 over negative 1. Tangent. Opposite over adjacent. So remember, this is the angle you're looking at right here. So it's 4 over negative 1, or negative 1/4. You okay with that? Everybody okay? Because now question C is where things get a little bit crazy. So I'm gonna have to erase this. Is there any number up there that's bothering anybody? You wonder where something came from. Before I erase it, let's get this taken care of. All right. So now I'm going to start the same way. I'm going to plot the point 0, negative 2. Tell me what is different. What crazy thing happens when I plot the point 0, negative 2? It's straight down here, isn't it? What'd you say? No butterfly bow tie. This is an issue, folks. This is an issue. You cannot draw your triangle. It's not possible. If the angle happens to be on an axis, so it could be here or here or here or here, you must use not your SOHCAHTOA definitions, but your circular definitions. Those are the ones that are on your sheet. We haven't used them yet, but I told you to get them memorized. Sine theta, y over r, cosine theta, x over r, tan theta, y over x. Some of you already have those learned. If you don't, you need them. When do we need those definitions? Whenever the angle is on an axis. As long as the point is out here somewhere, we can draw our butterfly bow tie, right? If the point is out here. But if it's on an axis, you have to do your circle. Now, they gave you the point, so they are literally saying to you, x is 0 and y is negative 2. That was in the problem. They gave you that information. What is the radius of our circle? 2, of course, it's 2. If that's the point, 0, negative 2, doesn't that radius have to be 2? 2? The radius will always be positive. Always. The radius is positive. X and y can be negative, but the radius will always be positive. So now I'm going to fill in my blanks. What is sine? Y over r. All right, so here we go. Y over r would be negative 2 over 2, which is negative 1. which means my cosecant is 2 over negative 2, which is also negative 1. All right, what's my cosine? X over R, so 0 over negative 2. Anytime you have 0 over something, the answer is 0. But when you flip that, you're going to get negative 2 over 0, which is undefined. I love the way Mrs. Hollis explains it. You can't sit on the egg. You squish it. Can't do this. Can't have a 0 in the bottom. Undefined. What's tangent? Negative 2 over 0. Y over x. Negative 2 over 0, which is undefined. But the cotangent is 0 over negative 2, which is 0. Crazy. Why am I doing this problem a little different? Why am I not using SOHCAHTOA? Because it's on an axis. Can't make a triangle. Don't have opposite and adjacent. Can't make a triangle. Alright, we can do one more. Now I got the point 3 comma 0. Uh-oh. 3 comma 0 is also on an axis, right? This is the next problem. 3 comma 0. It's on an axis. X is 3, y is 0. What's my radius? 3. It has to be 3, kids. Look, if this point's on the circle, which it is, your radius has to be 3. So let's use our definitions now and come up with all of our functions. So here are our definitions. Sine is what? What's the definition of sine? Y over R. So y over R would be 0 over 3, which is 0. When the zero's on top, it's 0. Ethan, you paying attention, sweet pea? Okay. Now, if the sine is 0 over 3, then the cosecant is, 3 over 0, which is undefined. What's the cosine? Well, it's x over r, which would be, oh look now, what's x over r going to be? 3 over 3, which is 1. And the secant will be 3 over 3, which is also 1. Now we're doing tangent. Tangent is y over x. So y over x would be what? 0 over 3, and when the zero's on top, the answer is 0. And then the cotangent, flip it, would be 3 over 0, which is undefined. So one more time, when they give you a point, like they've done in all these problems, they give us a point and say find the sine, cosine, and all that stuff. If the point is out in a quadrant, then you're going to draw one of your butterfly bow tie triangles and do SOHCAHTOA stuff. If your angle happens to be right on an axis, not sticking out somewhere, but right straight up and down or straight sideways, then you're going to draw your circle and figure out X, Y, and R and use these definitions.
Yeah.
Huh?
We got a 25.
No.
30.
No, 30.
No. Jason, chill out, relax. We're gonna do number 3 and then we'll be done. Okay? So they adjusted that a long time ago, Mason.
A and B?
We're gonna do A and B, but they're real fast. Here's what you're doing in problem A and B. All I want to know is, we're gonna leave when we get these two done. So maybe that'll be before 9:30, maybe that'll be after 9:30. Focus. I've got sine, cosine, so sine, cosine, and tangent. And all I want to know is, are they positive or negative? I don't care. I'm not looking for a number. I'm not looking for a fraction. I just want to know if they're positive or negative. So in the first one, A, it wants me to look between pi over 2 and pi. Now, pi is the same as 180. So pi over 2 would be 90. So what they're really saying is, look between 90 and 180. Now remember, when we label our angles, this is 0, this is 90, this is 180, 270, 360. That's how angles are labeled. We start here. So if we want to be between 90 and 180, where will I be? Top left, or I'll call it quadrant 2. So I've got some kind of triangle in quadrant 2. 90 to 180, between 90 and 180. I have no idea what those sides are, but I know this one's negative, this one's positive, and this one's positive. Now, the hypotenuse is always positive, so I'm not even going to think about that one. The hypotenuse is a positive number. Always, always, always. Why do I know this one's negative? It's going left. Here's the origin. If I were going to plot this point, would I have to go left and up? So left means this part's negative, up means that part is positive. Now, when I do sine, I do opposite over hypotenuse. Opposite over hypotenuse. That would be positive over positive, wouldn't it? So the answer to the question is, it's positive. I don't have any numbers. It's not like 2/3 or something. It's just positive. Now what about cosine? Cosine would be adjacent over hypotenuse. Adjacent over hypotenuse, which would be a negative number. And what about tangent? Opposite over adjacent would be negative. All right, let's try the last one. Where am I looking this time? It says between pi and 3 pi over 2. So tell me what that means. What would that mean? Between pi is 180. Pi is 180. A half a pi is 90. Times 3 is 270. So I'm looking between 180 and 270 now. So where will I be looking if I'm looking between 180 and 270? Quadrant 3. So I've got my triangle, my butterfly bow tie, drawn between 180 and 270. So that's quadrant 3. Now tell me about the sides, positives and negatives. This one is negative. This one is negative. And this one is always positive. In quadrant 3, kids, you're going left and down. Negative and negative. So tell me about the sign. Opposite over hypotenuse. What's the sign going to be? Negative. It's negative over positive, which is negative. Opposite over hypotenuse. Tell me about the cosine. Negative over positive. Tell me about the tangent. Negative over negative, which is positive. So your tangent is positive. All right, you're going to flex now. I'll be in the atrium if anybody wants help.
This board, how can the side of the triangle be negative?
That's a great question, Luigi. The negative just gives us a direction. The actual length of it would be 6, but if we say -6, then we know the triangle is going down. So those of you that have my calculators, I need them back. And did you get yours back, Avery?
Yeah.
Okay. So Maddie.
But I thought it was like a small sheet.
Ellie, can you turn the video off, please? Thank you.